It began with a cosmic heresy, a single glaring impossibility that violated a fundamental law of the cosmos. The object's tail was pointed directly at the sunday. For any student of astronomy, this is axiom number one. A comet's tail, a gossamer banner of dust and ice, is always pushed away from its star, swept back by the relentless pressure of solar wind. But this visitor, the interstellar object now cataloged as 3I divided by Atlas, refused to obey. Its tail turned inward, a glowing plume reaching back toward the very source of its own potential destruction. It was a paradox, burning brightly, where physics insisted there should only be erasure. At first, the global astronomical community was united in disbelief. The initial data streaming from observatories in Hawaii seemed like a simple equipment flaw, a misaligned sensor, a calibration error, a ghost in the machine. But then, Chile's Very Large Telescope reported the exact same anomaly. Hours later, Gemini North confirmed it. The disbelief evaporated, replaced by a tense electric silence. Something was unfolding in the void that defied the language of our textbooks and the certainty of our equations. The story of a comet is usually a simple one. They are wandering relics, clumps of frozen gas, dust, and ancient ice born from the dawn of a solar system. But 3I divided by Atlas is not from our solar system. It is a true outsider, a fragment of another star's history that crossed the lightless gulf between worlds. It is only the third such object ever confirmed, following the enigmatic Oumuamua in 2017 and the more conventional 2I divided by Borisov in 2019. But this traveler arrived moving faster, shining brighter, and behaving like nothing nature was supposed to create. It sliced into our system at nearly 130,000 miles per hour, a velocity that could cover the distance between the Earth and Moon in just over 3 hours. At that speed, the slightest impact should have been catastrophic. Yet, the object was unnervingly stable, seemingly indifferent to the gravitational tides and solar forces that should have perturbed its path. It didn't slow where it was expected to slow. It didn't tumble in ways physics demanded. To tracking software built on predictable orbits, 3I divided by Atlas was a phantom, slipping through algorithmic nets, appearing on screens only when operators dared to push the parameters beyond their design limits. Initially, the official statements were models of scientific caution. Another interstellar visitor, the press releases said, then its light curve began to tell a different story. The object's brightness didn't just fluctuate, it pulsed. It would intensify, dim, and then intensify again in a perfectly repeating cycle every 19 minutes. This wasn't a random flicker, it was a rhythm confirmed by telescopes on 3 continents. Too precise for natural rotation, too clean for chaotic outgassing, it was a clockwork in the void, and each pulse was synchronized with a subtle flare in its impossible sun-facing tail. When the Keck-2 telescope broke down the object's light with its high-resolution spectrograph, the puzzle deepened. The expected signatures of water vapor were almost absent. Instead, the data was dominated by carbon dioxide, cyanide, and most astonishingly, glowing lines of nickel vapor, heavy metals, superheated to temperatures that should have destroyed them. The readings showed 2 opposing forces at work: normal cometary material streaming away from the sun and a stream of nickel ions accelerating toward it. A comet with a tail pointing in both directions. Scientists scrambled for a rational explanation. The simplest was perspective. Perhaps Earth's orbital position created an optical illusion, like a mirage on a hot road. Such anti-tails are known phenomena, but they are tricks of geometry, visible only when Earth crosses a comet's orbital plane. But the math failed. The angles were wrong. The plume was real, measurable, and growing by thousands of kilometers each day. Within weeks, It stretched nearly 100,000 kilometers, a glowing emerald spear aimed at the heart of our solar system. Harvard astrophysicist Avi Loeb, already known for his controversial theories about Oumuamua potentially being an alien artifact, was one of the first to voice the growing unease. The anti-tale of 3I divided by Atlas, he wrote, isn't a mere curiosity. It's a warning that our scientific categories are failing us. He cheekily rated the object a 4 on his self-devised Loeb scale for measuring the likelihood of artificiality. A 0 means unquestionably natural. A 10 would be undeniably technological. A 4, Loeb stated, represents something nature could do but simply never does. As the world's observatories raced to gather more data, a disquieting question rippled through the private channels of research teams. How much of what we see in the cosmos is real, and how much is just what we've conditioned ourselves to expect? By late August, the anomaly was the central topic of nightly briefings. The European Southern Observatory acknowledged unexplained sunward emission features, while NASA remained conspicuously silent. Then, on the 19th pulse, the anti-tail blazed with 10 times its normal brightness for less than a second, a brilliant spear of light stabbing toward the Sunday. Sensors registered a spike in infrared radiation that matched no known cometary spectrum. The energy was concentrated in a narrow band, looking less like chaotic heat and more like a coherent, focused emission. Some called it a chemical coincidence. Others, in private correspondence later leaked online, called it something else. One NASA engineer described it as a glint too clean for chaos. Another noted that radar echoes from the Deep Space Network, NASA's global array of antennas for communicating with distant spacecraft, showed a stronger reflection than porous ice should allow. The nucleus, they speculated, might be metallic, dense, maybe even hollow. As the object neared the Sun, another impossibility emerged. Instead of accelerating under gravity's pull, it began a slight, almost imperceptible deceleration. Its trajectory flattened until it was aligned almost perfectly with the plane of the planets. The statistical odds of this happening by chance are less than 1 in 100,000. To an engineer, that suggests precision. To a philosopher, it suggests intent. The object then survived a direct hit from a coronal mass ejection, a solar flare that should have torn it apart. It emerged from the blast of superheated plasma, not just intact, but completely undimmed. Whatever it was made of, it was stronger than rock. Tracing its path backward, astronomers pinpointed its origin to a region near the constellation Lyra. Statistically, the arrival of 3 interstellar objects, Oumuamua, Borisov, and now Atlas, from the same general quadrant of the sky in a single decade is a profound statistical anomaly. Something connects them. This is where the story darkens. For the global defense networks that monitor near-Earth space, 3I divided by Atlas was more than a scientific puzzle. It was a stress test. Its velocity and erratic behavior exposed the fragility of our planetary tracking system. So when data from Europe's ExoMars orbiter suddenly went dark and NASA's public servers switched to maintenance mode, on the same day the anti-tail flared, silence bred speculation. Was it a cover-up or confusion? In truth, science often pauses not to hide the truth, but to verify it. Yet every hour without new data fueled a storm of theories, from alien probes to interstellar debris from a long-dead civilization. As it prepared to slip behind the sun, invisible to every eye on Earth, 3I divided by Atlas was no longer just a comet. It was a question. Why does it defy the script? Why does it face the fire? And what does that say about us, a species that builds models of the universe, only to have the universe refuse to stay within the lines we draw? Disappearance in astronomy is never an absence. It is anticipation. As 3 I divided by Atlas vanished into the sun's glare, observatories kept listening. And then something impossible happened again. The Deep Space Network, our planet's most sensitive ear, continued to pick up faint, periodic bursts from the exact region where the object was hidden. The timing was perfect, one burst every 19 minutes. The sun's plasma should have drowned out any such signal. Yet the pattern persisted, a faint heartbeat in a storm of solar static. One analyst described it as a rhythm buried in noise, too coherent to be random. The word that no one wanted to use officially began to appear in internal memos: transmission. When 3 I divided by Atlas finally reemerged weeks later, it had changed. Its light was softer, greener. The anti-tail was fainter, but still defiantly pointed toward the Sunday, and then the clock shifted. The pulse was no longer 19 minutes, it was 23. Astronomers call this period drift, but this wasn't decay, it was a progression. The sequence of intervals, 19, 23, 27, 31, formed a harmonic series. It resembled a mathematical pattern based on prime numbers, the kind of sequence intelligence systems often use to signal intentionality. But as one physicist cautioned, the universe is full of coincidences that look like design. Still, the coincidences mounted. The object's spin rate had stabilized to exactly 1 revolution every 57 minutes, a perfect integer, multiple of its original pulse. Nature rarely tunes itself to whole numbers. Machine do. Then the object slowed again. This wasn't the random braking of a body under drag. This was a series of minute adjustments. The only term that fit the data was course correction. And each time the trajectory shifted, the anti-tail flared as if the same mechanism was providing a subtle electromagnetic thrust. NASA's Juno spacecraft, on its mission near Jupiter, caught the first direct evidence. Its magnetometer registered a localized magnetic distortion, a field pulsing in sync with the object's light variations. The data, never publicly released, was stark. 3 I divided by Atlas was generating its own organized magnetic field. Here, the story transcends astronomy and enters philosophy. We define artificial as something showing design or purpose. But what if the universe itself produces systems that behave intelligently? As Avi Loeb noted in a late-night interview, if you stare at 3 I divided by Atlas long enough, you start to wonder whether we've been looking for others in the wrong places. Maybe the universe doesn't speak in radio. Maybe it speaks in motion, and the motion grew more complex. AI-assisted telescopes detected microfluctuations in the pulses that matched a binary rhythm, and in March, an unconfirmed report from the Indian Space Research Organization claimed a faint radio burst from the object near 1,420 megahertz. This is the hydrogen line, a universal constant, the very frequency SETI has used for decades, believing any advanced intelligence would recognize its significance. The report was quickly retracted, citing data contamination, but the number echoed through the astronomical community. Then came April 3rd. Multiple telescopes witnessed a final spectacular flare. For less than a second, the object outshone everything in its quadrant of the sky. The anti-tail erupted, not sunward, but sideways, perpendicular to its path, forming a luminous arc stretching 500,000 kilometers. The maneuver was small, elegant, and impossible. Its path had changed again, steering it onto a new trajectory that would carry it out of our solar system. The official explanation was unmodeled outgassing, but the math didn't add up. It looked like intention disguised as an accident. As if to punctuate the mystery, high-resolution images revealed faint points of light trailing the object. Debris or something else? In leaked European surveillance files, they were labeled companions. 6 of them maintaining formation as the primary body accelerated away. Today, 3I divided by Atlas is once again a receding speck of light. NASA's official conclusion is no evidence of artificial behavior, a rare but natural alignment of dust and perspective. The headlines have ended, but the data remains terabytes of telemetry, filled with patterns that still beat like a buried heart. For those who watched, something fundamental has shifted, not in the sky, but in the mind. Because once you see a law of nature bend, you can never quite trust that our understanding is complete. You begin to suspect that the universe is not a machine to be figured out, but a living mystery. A comet that turns its tail toward the sun isn't rebelling against physics. It's demonstrating that physics is far grander and stranger than we ever imagined.